All right, so again, we are continuing to talk about scatter plots and statistical analysis. Today it says students use technology to determine the least squares regression line from a given set of data. And then we're going to use that regression line to make some predictions. So to take us back to where we were on Tuesday, if we look at this, we were talking about scatter plots and then deciding whether it was a linear representation or a non-linear representation. So this one says Kendra likes to watch crime scene investigation shows. She watched a show where investigators used a shoe print to help identify a suspect in the case. She questioned how possible it is to predict someone's height from their shoe print. So to do that, she collected a bunch of data. She collected data on the shoe length in inches and height in inches from 10 adult men. And here's her data, right? So again, if we look at the X, this person had a 12.6 shoe length and they were 74 inches tall. And again, that data is also on the graph, and those 10 dots represent each adult male. So if we keep going, it says, is there a relationship between the two? So could we draw a line and represent this? If I drew a line like this, are most of the points, are they even on both sides of that line? Does that help represent the data? Yeah, I think it kind of does, right? So that tells us that there is a relationship. And then it says, how would you describe it? Is it strong or weak? I would say, again, if we draw that line in, that it's not a strong, it's not a strong relationship, right? All the dots aren't right on that line. I would say it's a weak relationship, but it is clearly linear. We can draw a straight line that represents that data. And again, this is just like what we were doing on Tuesday. So yes, there is a relationship, and it is a weak linear relationship. And do the men with longer shoe lengths tend to be taller? Yes, on average, they tend to be taller. And that kind of makes sense, right? Most people with longer shoes or bigger feet also tend to be taller. And if we keep going, using models to make predictions. So you can use a line to describe the relationship. You can also use the equation to predict values. So for example, the line y equals 25.3 plus 3.66x could be used to describe the relationship between shoe length and height, where x represents the shoe length and y is the height. So to predict the height of a man with a shoe length, with a shoe length of 12 inches, we would substitute 12 in for x in the equation and then solve it. So just like we were doing before, but now we're talking about real situations. So we would substitute that 12 in and multiply it by 3.66 and then add 25.3. And we would predict that they would be around 69.22 inches tall for a man who had a shoe length of 12 inches. So if we look here, it says, below is a scatter plot of two linear models. Y equals 130 minus 5x. That is the decreasing line because, again, if we think about it, we have negative 5 as our slope, and that will create a decreasing line. So again, if you want me to, I can draw a red line over that one. So the red one here that you see me drawing, that is that line. And the other line, y equals 25.3 plus 3.66x. So it says, which of these two models does a better job of describing how shoe length and height are related? So if we look at those red dots, which one looks like it goes as a better average of all those points? Then it says one of the men, and I think we already talked about that, clearly it is our second graph here, right? So this line looks like it is the one that would better represent it. So that is the positive slope and the increasing line. Then it says one of the men in the sample has a shoe length of 11.8, so that would be somewhere around here, right? And 71 inches. And that would be somewhere around here. So we need to make those 2 points meet and see which dot helps to represent them, and then circle that dot. So on your paper, you can just point it out. You can use a bigger circle to show it. You can annotate it like I am, but it's up to you. If we do that, here's what we should get. Yeah, so the positive one, the y equals 25.3 plus 3.66x is a better choice. And then the point is where 11.8 and 71 meet. That should be what is circled on my graph there. If we keep going, suppose you want to know how. You do not want to know this man's height, but you do know that his shoe length is 11.8. So you do not know his height, but you do know his shoe length. If you use the model y equals 25.3 plus 3.66 times x, what would you predict his height to be? So there's 2 parts here. You should have 2 answers. And if you use the model 130 minus 5x, what would you predict its height to be? So again, we're going to plug in 11.8 to both of these. And you're telling me if we plug that in or substitute it in for x, what would the outcome be? So I'll give everyone a minute to do that. And if we look at number 6, which model was closer to the actual height of 71? Is that model a better fit to the data? Explain. And then again, it's the last one says, is there a better way to decide which of the 2 lines is a better description of a relationship rather than just comparing one predicted value? And here's what we think. So if you plug it into our number that we predicted, our first model that we said was better, you'd get 68.48. If you plug it into the second model, you'll get 71. So the 130 minus 5.8 was closer to the actual value, but it's not a better model because it is actually further from most of the other points. Although it's dead on for this specific point, the other model is better. And then again, if we think about it, the better line that is a better average for all of the points, not just one, would be a better one to use. So I'll give you a minute here if you want to look at these and copy any of these down, and then we'll keep going. All right, residuals. One way to think about how useful a line is for describing a relationship between 2 variables is to use the line to actually predict y values for points in the scatter plot. These predicted values could then be compared to the actual y values. For example, the first data point in the table represents a man with a shoe length of 12.6 inches and a height of 74 inches. So if we use the first line, you would get 71.42, which is fairly close to 74 inches. If you use the second line, and again, his predicted height again is 71.42 inches because his actual height was 74 inches. So now we can calculate the prediction error by subtracting the 2 values from the actual value. So if we take 74 minus 71.42, you get 2.58, and that is called the residual. So again, that is taking your estimation or your guess when you plug in or substitute in and subtracting it from the actual value. And the larger that value is, the bigger error value that there is. So if we look at this, we are going to take a minute and look at it and calculate some of these answers. So why is the residual? So the first thing we're going to do is plug in some values here. So the predicted y value, if we have a shoe length of 11.8, so if we plug in 11.8, multiply it by 3.66 and add 25.3, we'll get the values, the predicted y value. And then if we take our height and subtract our y value, that will give us our residual. So if we go ahead and do that, so go ahead and fill in the blanks. Again, you are going to plug in the x value into the equation. So here are our x values, and this right here, your job is to plug them in to the equation for x. So you'll have 3.66 times whatever value here is, and that is how we're getting our predicted y value. So that's what you'll do for the next two, and then down at 12.2. And then to get your residual, again, you're going to take the height and subtract the predicted value. So I will give you some time to do that, and then we will keep going. So if we keep going, here's what you should get. And the actual value, if we look at 9, why is the residual in the table's first row positive and the residual in the second row negative? The actual value is larger than the predicted value in the first row, so the difference is positive. And then if we look at the second one, where it is negative 3.49, it's actually less than the predicted value. So when you subtract them, you would get a negative number. You can have a positive and a negative residual value. So it says, what's the sum of the residuals? Why do you get a number so close to 0? Does this mean that the residuals were close to 0? So the sum of the residuals is negative 0.6. The number is really close to 0, which means that the equation here we're using is very close. But not all of them are close to 0. Some are, some are not. So if the residuals tends to be small, what does that say about the line? That all of the points tend to be close, that there's a strong linear relationship. So again, the smaller the residual value is, the closer the points or observation marks are to the line. And again, that's all that is saying. So if the residual is small, it means that all of the data is close to the line and that the line is a good fit. And we are going to stop there for the day. So don't worry about those last couple. Your job now is to go ahead into Khan Academy and you are going to look at the residual scatter plots. So there is some stuff on those right in there.